Welcome to our first video in object-oriented programming in C++. We are going to be learning how to do object-oriented programming in C++ using this book here by Robert LaFleur. This is the 4th edition book. This is a very, very good book. It's very detailed. It's got over 1,000 pages. So in this video series, it's going to be another databasetutorials.com video series on YouTube with another playlist for object-oriented programming. And we're going to be following along in this book. It's about 1,000 pages long, 1,038. And we're going to be using Microsoft Visual Studio along with it to gain an understanding. So let's take a look at this book a little bit and let's just see some information on it. This is what we're going to be referencing here. So this was copyright 2002 by Sam's Publishing. So this is all rights reserved. No part of this book shall be reproduced, stored in a retrieval system, or transmitted by any means, electronic, mechanical, photocopy, recording, or otherwise, without written permission from the publisher. No patent liability is assumed with respect to the use of the information contained herein. And although every precaution has been taken in the preparation of this book, the publisher and author assume no responsibility for errors or omissions, nor is any liability assumed for damages resulting from the use of the information contained herein. So, just some copyright information on this book. Let's take a look at the overview here. Looks like we start off with an introduction, we get to the big picture, and then we go into the C++ programming basics. And that's what we're going to be covering first, and then we'll be moving on into loop and decisions, and so on. So we're going to be starting off with chapter 1, which is going to be the big picture on why do we need object-oriented programming. So I'm going to jump on over to page 10. Let's read on and see why it is that we need object-oriented programming. Well, object-oriented programming was developed because limitations were discovered in earlier approaches to programming. To appreciate what OOP does, we need to understand what these limitations are and how they arose from traditional programming languages. Procedural languages, C, Pascal, Fortran, and similar languages are procedural languages. That is, each statement in the language tells the computer to do something. Get some input, add these numbers, divide by 6, display that output. A program in a procedural language is a list of instructions. For very small programs, no other organizing principle, often called a paradigm, is needed. The program creates the list of instructions and the computer carries them out. Divisions into functions. When programs become larger, a single list of instructions becomes unwieldy. Few programmers can comprehend a program of more than a few hundred statements unless it is broken down into smaller units. For this reason, the function was adopted as a way to make programs more comprehensible to their human creators. The term function is used in C++ and C. In other languages, the same concept may be referenced to as a subroutine, a subprogram, or a procedure. A procedural program is divided into functions, and ideally at least, each function has a clearly defined purpose and a clearly defined interface to the other functions in the program. So, I'm not going to go too in depth. That kind of gives us an overview of why we would need object-oriented programming. It'll help even the user that's doing the developing. The human eye will be easier to understand and comprehend the code that's being written when OOP is being implemented, especially when classes and methods and functions are being used with a similar name as to the object that you're referencing in real life or in the application that you're programming. So the object-oriented approach, the fundamental idea behind object-oriented languages is to combine into a single unit both data and the function that operate on that data, such as a unit, which is called an object. An object's functions, called member functions in C++, typically provide the only way to access its data. If you want to read a data item in an object, you call a member function in the object. It will access the data and return the value to you. You can't access the data directly. The data is hidden, so it is safe from accidental altercation. Data annex functions are said to be encapsulated into a single entity. data encapsulation and data hiding are key terms in the description of object-oriented languages. If you want to modify the data in an object, you know exactly what functions interact with it. The member functions in the object, no other functions can access the data. This simplifies writing, debugging, and maintaining the program. And so what that basically means is it's a lot easier to modify code in object-oriented programming and access its data and functions because you'll have private members and methods within those objects, which would be a lot more easier to understand. A C++ program typically consists of a number of objects which communicate with each other by calling one's another member function. The organization of a C++ program is shown here in this figure below. As you can see, we have an object, a data, a member function, and another member function. And then we have an object, a data, a member function that accesses another object, and all these three of these objects access each other. So this is the object-oriented diagram here that we can use. So this is just a quick introduction here. In our next video, we're going to be moving into some of the C++ basics in object-oriented programming, and we're going to be doing some hands-on here in Microsoft Visual Studio. So if you're interested in our next video, head on over to YouTube and databasetutorials.com. Don't forget to subscribe to our YouTube channel. We also have a SQL Server series up right now that we're also working on putting videos up. So thank you for watching, and see you next time.